This section, we're going to analyze patterns of chemical reactivity. And there's three types of reactions that we're going to analyze. First, combination reactions. Second, decomposition. And third, combustion. So, in a combination reaction, we have two substances forming one product. And an example of one of these reactions would be carbon monoxide, which is CO gas, plus oxygen as a gas. Remember, oxygen's diatomic, giving CO2 as a gas. We have two of these substances forming one product. So, as always, we need to make sure that these are balanced. If you notice, we have 3 oxygens on the left and 2 over on the right. So we're going to need to put a 2 in front of the CO2. That'll give us 4 oxygens and 2 carbons on the right. We need 2 carbons now over on the left, so we'll need to put a 2 in front of the CO, which now will give us 2 carbons and 4 oxygens on each side of the equation. Another example of a combination reaction would be SO2 gas plus water in the gaseous form, giving H2SO3, also in the gaseous form. Now we have to make sure this equation is balanced, and if we look, there's 1 sulfur on the left, 1 on the right, 3 oxygens on the left, 3 on the right, 2 hydrogens on the left, and 2 on the right. So this equation, as written with coefficients of 1 in each case, is totally balanced. So there's 2 examples of combination reaction. The next example would be decomposition. In a decomposition reaction, it's actually the opposite of a combination reaction. Here we have 1 reactant yields 2 products. In this case, an example would be something like calcium carbonate, which is CaCO3, as a solid. If we heat this up, it becomes calcium oxide as a solid plus CO2 as a gas. We need to double check to make sure this is balanced. We have 1 calcium on the left and 1 on the right, 1 carbon on the left and 1 on the right, 3 oxygens on the left, and 1 plus 2 or 3 oxygens on the right hand side. So that is balanced. And typically with these decomposition reactions, you need to put some type of energy or heat them or do something to break down what that reactant is. Some of them happen spontaneously, but in most cases we need to apply some type of energy to push this reaction forward. Another example of this is if we have water in its liquid form and we perform electrolysis, we can get the products hydrogen gas and oxygen gas. In terms of balancing this particular reaction, we have 1 oxygen on the left and 2 on the right. So we need to put a 2 in front of the water. That gives us 2 oxygens, but now we have 4 hydrogens on the left, and we need 4 on the right. So we need to put a 2 in front of the H2 gas. So there's 2 examples of decomposition reactions. The last main form of reactions that we're going to look at is something called a combustion reaction. And in a combustion reaction, typically we have a hydrocarbon plus oxygen gas. It's going to be heated to give us CO2 as a gas plus water. So oxygen always shows up as a reactant, and the products in a combustion reaction are always going to be CO2 plus H2O. This defines and characterizes what a combustion reaction is. So let's talk about how we might balance one of these combustion reactions. So we'll give an example of C7H16 as a gas plus oxygen as a gas. If we heat these up, this is going to give carbon dioxide plus water. And again, remember, combustion reaction, we're always going to see oxygen as a reactant and CO2 and H2O as products. In these combustion reactions, I think taking the following steps would be important. One, you want to first balance the carbon. Second, you want to balance the hydrogen. And third, balance the oxygen. This is going to be very, very helpful, and if you follow this order, you're going to make it a lot easier on yourself. So first we have C7H16. Okay, so there's 7 carbons on the left and there's only 1 over there on the right. So we need to put a 7 in front of the CO2. Now we have the carbons balanced. Next comes the hydrogens. In terms of the hydrogens, we have 16 hydrogens on the left and only 2 on the right. So we need to put an 8 in front of the water on the right-hand side. Now we need to count up our oxygens. We have 7 times 2, or 14, plus 8 times 1, or 8. And 14 and 8 is going to be 22. So in order to get 22 oxygens on the left, we need to put an 11 in front of the oxygen gas. So and this is going to give you kind of a way to look at these combustion reactions and figure out the best way to balance them, because remember, balancing chemical equations is very important for everything else that we're going to study involving calculations around this topic.